Hi, everybody. How's it going? Let's talk about orchestration. Raise your hand if you know what that is. All right, that's a good chunk. Good. Great. Specifically, we are going to talk about what it is, why you use it, and when. Go off into a fairly long digression on how to use it. Talk about the cool new features in Puppet Enterprise 3 for orchestration. And go into some concrete use cases. The amount of time devoted to each of those is going to be a little slidey, so we'll see what happens. Here's a cool thing about this talk. I already took notes for you. I am a technical writer at Puppet Labs, so I work on the documentation, which is available at docs.puppetlabs.com. And I actually wrote the part on orchestration in Puppet Enterprise 3. And so at a couple of points, I'm going to point you to where to look so you can remember the stuff I was talking about so that you won't have to take notes. Save you some time. OK, what's orchestration? It's not configuration management. It is a different kind of automation that complements configuration management. If we think about config management as being modeling a desired state for systems, enforcing that desired state, and then updating the model in order to update the state, orchestration is instead about executing actions on demand on a flexible group of systems. What's that mean? Take it step by step. What is an action? In the orchestration engine of Puppet Enterprise 3, predefined actions are distributed as plugins. So it's not like SSH where you just log in and run whatever command happens to be there. The actions are set ahead of time. You can add new actions, but the point is that the actions are well defined. The second point is that actions have structured inputs and outputs. On the command line, you may or may not notice a difference between structured data and just descriptive data. But if you're trying to hook up the orchestration engine to build a larger application, you will notice immediately. One of the strengths of the orchestration engine is that any new actions you add have such good structure on their inputs and outputs that you automatically get a web UI in the Puppet Enterprise console. We'll briefly touch on that. And actions, as for what the actions can really do, is pretty much whatever. You write the plugin, you define what the action does, and it can be anything that fits into your day-to-day business. And again, we will touch on that a little bit later. What does it mean to say that we run actions on demand? It means whenever you want, and it can mean either really quickly and in parallel, or in a controlled series of batches. Let me clarify a little bit. In a system like SSH in a for loop, or even in parallel SSH if you're really fancy, you have something of a limit on how many machines can run actions at once. Because the client machine that is triggering the actions has to have enough processing power to dial into each of them, manage the SSH, the cryptographic connection between each of them, and manage the sort of output from the shell on each of them. The orchestration engine works a little bit differently. It's based on a message bus system with all agent nodes listening for messages. And when you send a message to a large group of nodes to run an action, they all receive the message simultaneously, they all run simultaneously, and they all deliver their replies, which you can process at your own speed. The controlled series of batches part is a new feature in the Puppet Enterprise 3 orchestration engine, and we will touch on that later. I'm saying that a lot. What does it mean to run an action on a flexible group of systems? This is where the orchestration engine really shines, and it's one of the coolest things that you're likely to see the first time you install Puppet Enterprise. It's really cool. Instead of using a list of host names like you would with SSH in a for loop or PSSH, you instead set criteria to match against when you issue a command. You can say all nodes that are running CentOS 5.7. You could say all nodes that have the Apache class applied to them in Puppet. And you can even use dynamic data discovery to say all nodes where the last modified time of the etc hosts file is such and such. We actually have plugins that can inspect files on disk and collect those into groups of nodes. So yeah, that's maybe a little bit dizzying, but that hopefully shows you what I meant by executing actions on demand on a flexible group of systems. So why use orchestration? There's a couple of reasons. For controlling config management, out of the box, the orchestration engine has a large number of actions for controlling Puppet, for finding out the status of Puppet on all of your nodes, for triggering no-op runs, stuff like that. It's really a force multiplier for Puppet by giving you the ability to do things on demand instead of on a schedule. For gathering information, you can use the orchestration engine as sort of a lightweight monitoring and reporting tool, where you're getting the immediate status of any number of nodes out in your real infrastructure. For application deployment, this maybe takes a pause to talk about. With configuration management, you're often managing a steady state for a system. And steady states are really good as prerequisites for deploying an application. It can get a little trickier when you're trying to actually do the application deployment itself. Oftentimes, your applications are going to be running on multiple servers, and they're going to have multiple services that must work in tandem. And when you upgrade it, you kind of have to bring things down and bring them back up in a predictable pattern. That's tricky to do across multiple nodes. And there's often going to be a manual component to it. The orchestration engine lets you automate some of that manual component and do it a lot faster and a lot more predictably. Like I said, all actions are predefined, so when you've shipped around actions that help you with your application deployment, it's a little more foolproof than running a script. You can use it for routine or emergency maintenance. If you have accidentally shipped bad Puppet code and you need to shut things down and fix it, the orchestration engine is your best friend. It will shut everything down immediately. It will let you start and stop services, upgrade or downgrade packages, and it can let you do all kinds of other things as well. And ultimately, any of your day-to-day work that must happen interactively. That's kind of the fundamental difference between orchestration and configuration management. Orchestration is there as a force multiplier for any sort of interactive work you have to do, things that have to happen on command. So to sum up, what tasks do you want to run better on lots of nodes? That's the answer for what orchestration is for in your own infrastructure. All right, moving on to how do you use orchestration. We wrote this down. If you go to docs.puppetlabs.com/pe/latest and then look in the sidebar, which we will see over here, you'll see there's a whole section on orchestration. And the section that you want to refresh your memory on how to invoke actions is called invoking actions. It's a fairly long page. You can see the table of contents right here. This should have everything you need to know to start using orchestration today, which is why I'm going to be breezing over a little bit of the nitty-gritty of the how-to. Yeah, just remember how to get to this page. Go to the PE manual, look in the sidebar, orchestration, invoking actions. There's two ways to invoke actions in PE with the orchestration engine. One of them is in the PE console on the live management page, and one of them is on the command line. We're going to focus on the command line today because that's where a lot of the newest features in the orchestration engine in PE3 are available. Right now, PE3 was a major platform upgrade, and we made available a lot of new features on the command line first, and they're going to start filtering into the GUI applications over time. So you've basically got a three-step process when invoking actions on the command line. You go to the command line, become the PE admin user on the Puppet master server. You decide on three things. What action do I want to run? What inputs and arguments do I want to give it? And on which kind of nodes do I want to run this action? And finally, you run your command. It's always going to start with the MCO command. It's going to have a subcommand in there. That subcommand will have some arguments, possibly some options, and almost definitely a filter. We mentioned actions and inputs. We have a list of those in the Puppet Enterprise documentation, the list of built-in actions. There's also help on the invoking actions page where we talk about how to get interactive help on the command line, especially for actions and plugins that you developed and shipped around to your nodes yourself. We mentioned filters. For finding filter information, you definitely look on the invoking actions page, and you look in the filtering actions section. It's pretty in-depth. And without further ado, let's actually just run some actions live. What I rigged up here is we have about 5. Well, first let's become the PE admin user. This is mentioned in the docs how to do this. And we're going to run mco-ping with no filter. Mco-ping is a subcommand that just tells us how fast things are responding. It's going to be a little embarrassing because these VMs are a little resource starved. Oh, that wasn't too bad at all. There we go. That's our 5 VMs that are hooked up to this collective. Let's try this with a filter. With a class, Puppet class, Apache. All right, that's 2 nodes that have class Apache. See who has MySQL Server. That is 1 node. I'm going to bring this up a little bit so I can see it a bit better. There we go. So you can see how filtering is starting to work. This is information that's not in a central database, although you can query a central database for discovery. We are actually asking each individual server, sending out a broadcast message and saying, please respond if you match this filter. So let's do something a little more interesting. We're going to say mco, oops, might be a little bit slow here. Mco service, MySQL D, status. Sorry for the dead air here. Undefined method for no class. That's odd. There we go. So I just went searching for the HTTP service, got our status. We have a summary of the results right here. Stopped on 3 nodes, running on 2. And you can already start to see here how you can start use the orchestration engine as a lightweight monitoring or reporting system. The service plugin has an action called status that it works very similarly to the sort of local tools that you're used to that just run the init scripts. But it runs it across any number of nodes at once and gives you your results like that. So we see that we have some nodes mixed in here that probably don't even have Apache installed. So let's try to run that command with a filter. We're going to say with the Puppet class Apache, and that will limit that command to the nodes that have that class. We'll see 2 of them come back. So everything that's supposed to be running Apache is actually still running it. That's a bit different than what we saw up ahead, which was where we had 3 systems stopped. We filtered those out by saying, all right, well, those systems probably don't even need to be running HTTPD. Let's go ahead and stop the service. Come on. And there we go. We stopped it. So this isn't super interesting when you're seeing it happen to 2 nodes at once, because that's a fairly easy problem to deal with. When you're dealing with many, that's when it starts to really come into its own. So what did we just see? We were using the mco command, which controls the orchestration engine from the command line. It has a bunch of subcommands whose syntax can vary. And we're going to run through a couple of those right now. The mco RPC subcommand is the generic one. It can actually run any action from any plugin. The syntax is sometimes a little bit verbose. When you're doing one of those, it's mco RPC, the name of the plugin, the name of the action, and then a series of input equals value pairs, and then any actions or filters. All of the other subcommands are often just simpler ways to do things you could already do with mco RPC. You saw me use one of those. You saw me use mco service. That mimics the structure of the familiar service commands you see on platforms like Red Hat and Ubuntu, where you say service, name of service, stop, stuff like that. On the other hand, the package subcommand mimics the format of the apt and yum commands that you're used to. So instead, you would say mco package install name of package. Those are just there as shortcuts. In all of those cases, you could get the same result by using mco RPC. And finally, mco Puppet is for controlling Puppet. So let's take a look at some of that. We're going to use a special action here that summarizes the recent activity of Puppet on all of our nodes. You can see that it gives you some little sparkline graphs. Those are a little bit messy at the moment just because the window is a little bit miniature. But you can see that it shows you the total resources on all of your systems, the out-of-sync resources, the failed resources, changed resources, config retrieval time. It's a great way to check the sort of health and load of your Puppet system on demand. This is one of the new features in the orchestration engine in PE3, the ability to summarize and graph results like this. And let's show how to get help on the command line. When you do that, it always gives you a reminder of how to do the various filter types. You'll see the -F and the -C that you already saw me use. Some general options, and then near the top of any help output you get, you will see the various actions you can use with a subcommand and descriptions of them. Let's shrink that down a little bit more. Great, there we go, perfect. Right, so status lets you see the Puppet agent status. Run once lets you actually trigger a Puppet run. Disable and enable let you disable and enable all Puppet runs. And let's do a couple of those right now. We're going to say stop the Puppet agent service. We'll use the mco service command to do that. Yes. When I do this, all of my 5 nodes are going to stop doing scheduled Puppet runs. This is like I'm putting them into a maintenance mode. One of the best ways to roll out new Puppet code is to stop Puppet runs on a subset of nodes that you think are going to be affected, and then start doing no-op runs on all of them to make sure nothing untoward happens. You can check no-op reports in the PE console, find out whether there were any changes that would have been made, find out whether there are any errors that would have come up, and edit your stuff after that. If I do mco Puppet status now, we're going to see in our summary of results that the Puppet service is stopped everywhere. None of them are idling. They are all enabled. So if I try to do an on-demand Puppet run, it will work. Whereas if they're disabled, it'll block me. The daemon is stopped, and none of them are currently applying a catalog. And you can already see the use of this as just a thing to do when you're about to do anything on your Puppet infrastructure. Let's use one of the really cool features of the Puppet subcommand. How many people here have tried to trigger Puppet runs and then accidentally overwhelmed their Puppet server? Yeah, it happens once in a while. We're going to use PE3's ability to do batched operations to slow that down a little bit and make sure the master does not get overwhelmed. This works with any action on any subcommand. There's a special case for Puppet that I'll show you in a little bit, but we're going to say mco RPC. This is the generic client I told you about. Puppet. Our action is going to be run once. We're going to say no filter, but we are going to say batch 2 and batch sleep of 8 seconds. So you can see how it reaches 2 and then it pauses for a little while. reaches for, pauses for a little while, and finishes real soon. This is great for progressive deployment of changes. By doing this, you get the ability to cancel out of things if you start to see problems. By using a large batch sleep, you can give your long-running processes a lot of time to finish up before the next batch comes in. And it lets you protect any sort of shared resource from getting stampeded by things that are going to be consuming it. The obvious use case for this is Puppet, and that's why the built-in tools are optimized for that. But this can work well for any custom actions that you develop and deploy as well. Let's go back to our slideshow here. OK, how about those new features? We just saw one of them. The batching and progressive deployment is for limiting the speed of changes. It's good for rolling out new Puppet modules. Oh, I just did that demo. Another new feature is data plugins and dynamic discovery. Now, you already saw me do discovery on Puppet classes and facts. But you can actually do it on much more complicated things, including whether Puppet is enabled, the status of various files, stuff like that. If you're looking in the docs, you can see down under filtering on the compound filters, we talk about data plugins. And we've got a steps here for finding out which data plugins are available, which inputs and outputs they take, how to best take advantage of them. We are going to use the Puppet one. We're going to use mco ping again, which we already saw, use a compound query, and we will say, I've got to remind myself how to do this. Right. Oh, that did not work. Well, let's use the built-in documentation. So this gives back all of the information that the Puppet data plugin gives us. We can see that the output includes applying, daemon present, disable message, enabled, idling, etc. Let's go ahead and disable Puppet completely on one of these. Go Puppet disable, use an identity filter, and right, now we start doing our discovery. This should find us all the nodes where Puppet is enabled. You'll see that there's 4 of them. This will find the ones where it's disabled. You'll see it's only 1. Now we can start using that discovery for more interesting commands, like Puppet enable. Just enable all of the ones where it was disabled. That's pretty easy. There we go. You can also use data plugins to simply retrieve data. That can be interesting, especially if you have data plugins that check the health of various services that you care about. Yeah, it's a really cool feature, brand new in PE3. Another new feature in PE3 is sampling and limiting. This is especially good for things where you want to sample the status of a service or the status of a piece of data, but you don't need to get a complete view of your entire infrastructure. You can limit the results to get only a few back. So if we expect that everything is in the same state, go puppet status -1. This is especially good if you're using filters and you can get a representative member of a filter. Yeah, just a nice little convenience. So the thing to remember about orchestration is that the built-in actions are really useful, but it really shines when you start rolling your own actions for your own business purposes out in the world. I think most of the orchestration plugins that currently exist are kind of subterranean. They're not really being shared by the people using them just because they're so specific. But we have a couple of examples out there in the wild. For example, here's one that Hunter Haugen, one of our employees at Puppet Labs, wrote. And this is one that adds and removes members to an HA proxy pool. And that's it. The entire plugin fits on one page here. You've got 2 files. Neither of them is particularly large. And that's all it is. You can write these pretty easily for your own purposes. It's a bit of Ruby code, but we've got documentation showing how to do it. You'll see that there's an adding new actions section of the Puppet Enterprise documentation, and there's a section with links to how to write new orchestration plugins. I seem to have wrapped up a little bit early. But I would love to spend a little more time demoing things, and I'd like to get some input from the audience, hearing what you'd like to see, especially. Yeah?
I had a very educational experience. We made a mistake and angered some people. Anyway, we needed to roll back a bunch of files that had been changed by Puppet. And Puppet whenever it changes a file, it saves a backup copy of what it used to be, and I think it's called the file vault. Anyway, so we scripted to roll that out, and I was wondering if there was anything integrated along those lines.
For replacing a file, rolling back a file. Yeah, I don't think there is. But here's a thought. If you've got file bucketing turned on, oh yeah, the file bucket. The Puppet plugin actually has an action that lets you modify any Puppet resource on the fly. That's another new feature in PE3, by the way. Much like you would do like you're familiar with this format of command, right? Where you're saying Puppet resource, a resource type, and then a specific resource. You can get back info about that resource. And you can even modify things by specifying like content equals whatever. There is an action that lets you do that as well. By default, it's not enabled. You have to change a config file to let it do this. But there's this special feature with the content attribute of the file type where if you set it to a checksum, it will fetch that content from the file bucket. Yeah, so let's find out whether that actually works. This is going to be a bit of an adventure for all of us. Let me figure out how to, let's see, I think file bucketing is turned on. The way to find out whether file bucketing is turned on is to check site.pp, and there should be a resource here. Yes, here we go. File bucket main, server, the Puppet master, path false, and we see that file backup main. This means file bucketing is turned on, and whenever Puppet replaces the content of a file, it will file bucket it on the Puppet master. Great. So that's in place. Now we just need to modify a file in Puppet's source to break everything. What is a good example? Well, in this case, let's just break ACK. feel like I added this to all of my nodes. This is just a really cool program that is kind of like grep, but better. And I'm just going to destroy the whole thing, I think. Yeah, let's do that. Look at it go. Yeah, all right, that's enough. Kill it. Let's make sure that this is actually on all the servers, I think, and that's easy to do with mcollective. We just say, with the orchestration engine, we say mco ping class ACK. Yeah, that was applied to all 5 of them. Great. So we will do a Puppet run. Oops. Puppet is still stopped on all of these. Run once with the identity filter, and we'll paste in the name of this. And that will run Puppet once on this node. That kicks off the run. If we start doing mco Puppet status, we'll see that it's probably still applying the catalog as we speak. Oh, it is not. It started the daemon, though. That's odd. Oh, no, that's right, because it kicks it off in the background with a splay value. So this might take a couple of minutes. In the meantime, let's get the MD5 sum of that ACK file. Where did I end up? I want to make sure that I'm looking in the right place for it. Looks like we were putting in user local bin ACK. Okay. We'll copy that MD5 sum. Great. That Puppet run finished. I wonder if we beat the if we managed to beat the Puppet run when we were finding that MD5 sum. We did not. Okay, but there's a quick way to find that, which is to take a look at the reports. We'll go to our Puppet Enterprise console here, refresh it, and it is probably going to make me log back in. Yeah, there we go. We have one changed. We can see that the MD5 of that content should have changed. Yeah, there we go. Here is the old content. And there's the new content. Great. So we're going to stop Puppet everywhere. Assume that we accidentally pushed some bad changes. Oh, that's right. It's called PE Puppet. There we go. Great. Now let's see if this magic actually works. Puppet resource. Well, here. let's check our format and make sure that this is what we think. We're going to go to the list of built-in actions. We'll see that the Puppet plugin has a resource action. Its inputs are name and type. And I do believe, and it's not shown there. There must be some optional. Arguments there that we can give. Yeah, resource type, name, and then property equals value, property equals value. Great. File, user local bin ACK. Let's go ahead and quote that just in case. Content equals this MD5 sum. Let's see if that works. No request sent. We does not discover any nodes. That's funny. There we go. Could not retrieve from file bucket. File not found. It's trying. That's interesting. I wonder if yeah, that's weird. Request aborted. Wow, that's a really anticlimactic end to that attempt. Sorry, everybody. But I would love to show people more cool stuff after this. Feel free to come up to me wherever I'm at, and I'll see what I can do. And does anyone have any questions? Yeah. A way to have it prompt for user input. Not with the default applications available. You would have to write a custom subcommand. And those are pretty easy to do, but they're a little bit tougher than writing your custom actions. Yeah, often you just have to give the inputs at the beginning.
In the documentation, is there an example of doing an application deployment, like a multi-tier deployment?
In fact, there is. Yeah, there's, the question was, is there an example of deployment, application deployment in there? There's a section called adding actions. And this whole page actually talks about what sort of boilerplate you need to post at the top of your Puppet modules. You'll see that there's some sample code right here. A description of what resources you need to make in order to put those new plugins in place. A description of how to configure plugins using the plugin.d directory, and a description of how to use policy files to control access to those new actions that you've added. Putting in custom subcommands works much the same way. It's simply that the file has to go into the application subdirectory instead of the agent subdirectory. And this shows you how to do it while restarting the orchestration service every time you deploy new plugins. So yes, hopefully this will fulfill your needs for learning how to do that. Yeah? So when you're doing progressive deployment, how can you find out about errors? Unfortunately, you have to monitor it through some out-of-band channel. And if you were doing Puppet ones with a large batch sleep, you would probably be looking for reports in the PE console. In order to do that, the results don't get printed and summarized for you by the orchestration engine until the command is finished. The ability to cancel out if you start seeing errors is nice. Mostly what it's for is preserving shared resources to make sure they don't get stampeded. Yeah?
If I want to manage an HPC cluster, could I use various influxes to power the nodes on and off via IPMI or ILO?
Almost certainly. I don't know. How? So let me ask a couple of questions. When you're doing that, are those when you're bringing nodes up and down that way, what system are you communicating with? Are you just giving that command to the node itself, or is there a controller node that you're talking to?
Well, the IPMI would be an embedded device inside the node that powers it up, that controls power, reset it.
Okay, and normally to make it control the power, would you be interacting with that via via the node's shell, or?
That would be separate from the operating system. So it's like the second cable goes into a NIC.
I see. Yeah, that's tricky. You would probably need to say. So I can think of a couple of ways. You could have one node that manages the sending the IPMI commands along that second NIC, like one kind of controller node, or several controller nodes, and then have which nodes they need to power on and off provided as arguments to the action. Another thing you could do, and this is kind of black magic, it's not really what the PE system is set up for, but I feel like it should be possible to write an M-collective agent, an M-collective daemon that instead of running actions on a server, runs actions on the IPMI interface. So you could have the control node, and then instead of providing which nodes to power on and off as arguments to the action, you could have that node generate a bunch of fake M-collective nodes and be able to send commands to those fake nodes, and then the system running those fake nodes would be able to translate that into IPMI commands. Maybe don't do that. That's the kind of thing that, yeah, that's some mad science. But what I'm thinking of in this case is Ari's collective builder tool that he used to make a bunch of simulated M-collective servers on a single laptop instead of having to spin up a VM for each of them. When he was using that, he was basically doing that exact same thing, creating a bunch of simulated nodes and then simulated responses. You could have that be triggering those IPMI commands. Exactly. Anything else? How do we recommend setting up highly available environments for M-collective? So we're actually working on a scaling guide for the entire Puppet Enterprise stack that we hope to publish sometime quite soon, with very, very easy to follow recommendations for how many servers to use for which service, including the ActiveMQ service that backs the orchestration engine. Unfortunately, we're not ready to publish it just yet because it requires a lot of vetting, and we're in the process of that right now. So my advice would be talk to the professional services team at the moment, or talk to the support team, and they can find out something that'll work for your system. Right now, in fact, the professional services engineers are using that guide to guide them when they set up systems for other people. It's just that we don't have it as a self-service resource yet. We hope to sometime in the coming months. And people are filing in, and that looks like we are done. Thank you so much, everybody, for your time. I hope that was helpful in some fashion, and thanks for coming out here. I'd be happy to talk to other people later.